Sorry, I had a little yawn there. Alright, so first step is step number 1. What do I do first? Find the domain. What is the domain?
All real numbers except x cannot equal.
I like all real numbers, but x can't equal positive 1.
Oh, yeah.
4x minus 4 equals 0. Add 4. 4x equals 4. Divide by 4. X equals 1. Right? Okay? Now, before I go on to my vertical asymptotes, what should I do first? I should simplify it first. Yeah. So let's factor this bad boy. So what are we talking here on top? X plus 5 and x minus 1. What are we talking on the bottom? 4 and x minus 1? Like that? Okay. So what does that mean? What cancels? The x minus 1's cancel out, right? Okay. So what does that do to my vertical asymptotes? That becomes none. Now, my domain stays that x cannot equal 1 because I can't put 1 into that function. Okay? So my vertical asymptotes become none. So my function really here then is, let me rewrite it over here. F of x here is equal to x plus 5 over 4. Okay? So then what is my horizontal asymptote? That's a none case too, right? Okay. What is my int? Okay, so that's like 1.25. Alright. What is my x? Oops, went too far. What is my x-intercept? Two, 3, 4, and 5 is right there. Okay. Do I have a hole? Yeah, because something factored out, right? Okay, so how do I find that hole again? X minus 1 equals 0, right? So x equals 1. And then I put that into my new function, right? So I find f of 1. So that's going to be 1 plus 5 over 4. 1 plus 5 is 6. 6 divided by 4 is 6 divided by 5 is, or 6 divided by 4 is 3/2. So that tells me that my hole is at the point 1 comma 3/2. Correct? Yes, 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 and yes. 1 comma 3/2 is right there. All right, so whoa, 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 and whoa. 1, 2, 3, 4 goes through there. 1, 2, 3, 4 goes through there. 1, 2, 3, 4 goes through there. There, and there. All right. So this actually ends up being a line. With a hole in it. There's a hole in my line, dear Eliza. Dear Eliza. How do I get the points? I went off the x-intercept. Okay? because this up here is really, I could have wrote this as 1/4 x plus 5/4, right? So my y-intercept is there, and then my slope is 1/4. Rise over run, up 1, run 4. So I went off of the only point that I knew there. Yes, ma'am. Sure. What is it? As x goes to positive infinity, what does my function go to? Positive infinity. As x goes to negative infinity, what does my function go to? Negative infinity. Yep. Yep. And because there is no horizontal asymptote for it to go to. Remember? That was one thing that I'm starting to get a little frustrated with. Okay? When remember, your function approaches asymptotes. It gets close to asymptotes everywhere. Right? Okay? So if you have an asymptote of y equals 2, your function, a horizontal asymptote, let's say, of y equals 2, your function at the extremes, at the end behaviors, is going to approach 2, not 0. Okay? People are still stuck in that it approaches 0 part. Those way back from when we started always approach 0 because all of our functions have asymptotes of y equals 0. Okay? It's not an absolute. Back when I told you that, when I introduced horizontal asymptotes, that's what your end behavior goes to, is your horizontal asymptote. Okay? All right? There was a lot of people still on this last week's quiz that were still going to 0 instead of to the horizontal asymptote. Okay? So, when determining that horizontal asymptote, great segue. We call that a segue in the biz. Okay? When determining the horizontal asymptote of a rational function, we compare the degree of the numerator to the degree of the denominator. First question is, what's a degree? First question is, what's a degree? First question is, what's a degree? The biggest exponent. Okay? It's not just an exponent. It's the biggest exponent. There is a difference. Okay? Whether you choose to believe it or not. So, when I compare the biggest exponents on the numerator and the denominator, what are my 3 options? Top is greater than the bottom is option number 1. If the top is greater than the bottom, what is my horizontal asymptote? That's a none. What's my second option when comparing the degree of the top and to the degree of the bottom? Top equals bottom. What is my horizontal asymptote in that case? Y equals A over B? And where do I get that A from and where do I get that B from? The coefficients. Yep. Okay. What's my third option? Top is smaller than the bottom? Or bottom is bigger than the top? And what's my horizontal asymptote in that case? Y equals 0. Okay? So for 2 of the 3 of those, we have a defined horizontal asymptote. Right? It's just that third one, that none case, that we have to look at. Okay? So we're going to focus our energy here today on this one. Okay? If we're in this case, there is one more check. Okay? And that one more check is if the degree of the numerator is 1 degree higher than the degree of the denominator, and there are no common factors, we get what is called a slant asymptote. Okay? If the degree of the numerator is 2 bigger than the bottom, we get what is called a quadratic asymptote. If the degree of the numerator is 3 bigger, we get a, you want to take a guess? Cubic asymptote. If it's 4 bigger, quartic, yep. Yep, quartic. 5 is quintic. We're never going to get more than 1. Yeah, we're never going to go more than 1. Okay? So, the much anticipated step number 6. We need to find that slant asymptote if the numerator's degree is 1 bigger than the denominator. Now, you may be saying to yourself, how is Lynn's going to be able to make us find this stuff? Okay? It's actually relatively painless. Okay? You just got to go off of prior knowledge. Okay? So, here's how you go about finding the slant asymptote. 3 quick and easy steps. Okay? So first, your function, let's call it f of x, is going to be some function divided by another function. Right? That's how we've described rational functions throughout this entire chapter. The function divided by another function. So to find the slant asymptote, you are going to divide out that scenario. So you are going to do p of x divided by q of x. You are going to do the division. Now, what are the 2 choices that you have to do the division? You have synthetic. What's the downfall with synthetic division? When does it not work? No? It only works if and only if the denominator's degree is equal to 1. So if I had x cubed over x squared, I couldn't use synthetic division. Okay? Another way of saying it, the denominator has to be linear. Okay? So we can use synthetic there. If not, what's our other choice? Long division. And long division works all the time. Okay? So those are two choices. Okay? So you're going to do that division. You're going to get yourself a result, right? That result is going to possibly, or will it, have a remainder? That result, will it have a remainder? Yes or no? Always? Logically speaking, will that result, after you do the division from part A, will it have a remainder? Always? Sometimes? Never. Read the words. Why always? Why? No, it doesn't. It never says always anywhere in there. What do you mean? Yeah, I understand that they're not the same functions. What do you mean? What does it mean if I get a remainder of 0? That it divides in evenly into that function above it, right? Okay? So if it divides in evenly into the function above it, that means there's a common factor. But what did the directions say to get rid of first? Common factors. You got to get rid of the common factors first. So you will always get a remainder in part A. Always. Okay? If you don't get a remainder, I hate to break it to you, but you screwed up in step 1.5. And we're on step 6. Okay? So that means your step 2, step 3, step 4, and step 5 are all wrong. Okay? Right? So you will always, that's a check to make sure that there's no common factors, because you better get a remainder there. Now, because I know you're going to get a remainder there, I can say this. You're going to drop it. Because I know you're going to get it. I don't even care about it. Because we're talking at infinity, that remainder is going to be worth nothing. Okay? All right? So we're going to literally cross out the remainder. What's left over is your slant asymptote. Okay? So part C here then is your slant asymptote. We'll call it your SA. Okay? VA for vertical asymptote, HA for horizontal asymptote. So it logically flows SA for slant asymptote, or your SA. Okay? What? A slantote? Okay? So your slantote is going to be equal to y equals sum mx plus b. And you're going to get that. This part right here is what is left over from part A. Oops, I forgot the word from. Now have all 8 steps that we use to graph any rational function. So let's go through them step by step on this one. Okay. So, step number 1 is what? Domain. What is the domain of this function? Do we agree? All real numbers, but x cannot equal 2. Okay. All right. Before we go on to vertical asymptotes, let's do step 1.5 first. Can the numerator be factored? No. Can the denominator be factored? No. So it's simplified. Okay. So that tells me what for my vertical asymptotes? X equals what? 2? It sounded like you said negative 2 there for a second. Must have been somebody's coughing or something. Okay? Ha! Ha! None. Degree on top is bigger than the degree in the bottom, right? Okay? So this is a none case. However, I'm going to make just a little mental note here because they differ by how much? And that's the kicker, right? That the top was bigger by 1. That tells me I'm going to have step 6.
More than 1, do we just like go about it as normal?
Okay. You would do it the same way. You would still divide it out. Okay?
Yeah.
And then just I'd still drop the remainder. And then you would still that whatever's left over, then that becomes your asymptote. So you have to graph then that parabola or that cubic or whatever. Okay. But we're not going there. Okay. All right. Step 3. I need to find f of 0. Well, that's going to be 0 squared minus 3 all over 0 minus 2. That's going to be negative 3 over negative 2, which simplifies to be 3/2. So that tells me that my int is 0, 3/2. Oops, I think I forgot to put my vertical asymptote on the graph. Oh, that is it. Yep, so far? Okay. Step 4. What's step 4? X-intercepts. How do I find my x-intercepts? Numerator equal to 0. So that's x squared minus 3 equals 0. So I solve that. X squared equals 3. X equals plus or minus the square root of 3. So that tells me that my x-intercept is at the square root of 3, 0, and negative square root of 3, 0. Right? What's the square root of 3? 1.7? 1.7-ish? Okay. All right. So 1.7, 0 is right there. Negative 1.7, 0 is right there. Okay. Step number 5 says was there a common factor? No. So is there a hole? No hole. Okay. All right. here we go. Step number 6. So in step number 6, I actually have to take x squared minus 3 and divide it by x minus 2. Okay? So if I do it long division way, x minus 2 would go out here. X squared plus 0x minus 3 would go inside. Right? And I would get x here, and then I'd multiply that through, and I'd get x squared minus 2x. I'd change the signs. I'd get 2x. I'd drop it like it's hot. I'd multiply that by 2. I'd get 2x minus 4. I'd change the signs, and I'd get 1. Right? Okay. Or I could say x minus 2 equals 0, so x has to equal 2. So that's the number that goes outside. 1, 0, and negative 3 go inside. Drop it like it's hot. Drop it like it's hot. Add them. And I get that. Right? Either way, I get the same thing. 1, 2, 1. 1, 2, 1. That was part A of step 6. Part B says what? Forget about that remainder. So I am going to forget said remainder. And that leaves me with a slant asymptote of y equals x plus 2. X plus 2 from the long division way, x plus 2 from the synthetic division way. Okay? Alright, so now that's got to go on the graph. So that tells me I have a y-intercept of positive 2, and then a slope of positive 1, which is up 1 and to the right 1, or down 1 and to the left 1. How is that going to go onto my graph? I got those dots all in there, but how is my slant asymptote going to go on my graph? Dash line, just like the vertical asymptote, just like the horizontal asymptote. Okay. How many zones does this graph have? These zones. 2, because I only got one vertical asymptote. So I got a left side of the vertical asymptote and I got a right side of the vertical asymptote. Right? Okay. Looking at the left side, do I have enough points to make it fit in to draw in that side? I would agree that we do. Okay? Because it's going to come up. Here's the 3 points that are on it. So there's my curve. It's going to come up. It's going to go down. It can't cross that vertical asymptote, so it's going to head down to negative infinity there. And then this one is going to come up, and it's going to slide along my slant asymptote and go out that way. But I need to figure out what's it doing on the other side, right? Okay, so let's try some points over here. So I would go with 3 and 4 for sure. If I put 3 into my function would be 3 squared is 9, minus 3 is 6. 3 minus 2 is 1, so that tells me it goes to the point 3, comma 6. 1, 2, 3. 1, 2, 3, 4, 5, and 6 right there. If I put in 5, let's say. Oh, wait, I said 4. Okay, that's fine. 4 squared is 16, minus 3 is 13. 4 minus 2 is 2. 13 minus 2 is, or excuse me, 13 divided by 2 is 6.5. So that would be right there. Enough, or do we want one more? I think that's enough, because it's going to come in along my slant asymptote, and then it's got to curve and go up. Okay. Now, can I do end behavior for this graph? Yeah. So as x goes to positive infinity, where's my function going? It's going to positive infinity. It's shooting off up that way. Okay? So as x goes to positive infinity, my function's going to positive infinity. As x goes to negative infinity, it's going to negative infinity. Can I still do asymptotal behavior? Yeah, because asymptotal behavior is only around the vertical asymptotes. Okay? So as x approaches 2 from the left, my function is going negative infinity. As x approaches 2 from the right, my function is going to positive. Yeah? Ready to try one on your own? Go for it. Move this down a little bit. And I'm going to say that this is really x minus 5 and x minus 1 all over x minus 2. Okay. So my domain is all real numbers, but x cannot equal positive 2. Right? Simplifying, I already did the simplifying. I actually did it. It's kind of a step 0 instead of step 1.5. Nothing canceled out. So that means my vertical asymptotes here is x equals positive 2. Huh? HA. Horizontal asymptote. None, right? Top's bigger than the bottom. By how many? That's a none case, right? So they differ by 1. So that means that tells me I have step 6. Now is into play. Okay? My y-intercept, if I put 0 into my function, I get 0, negative 5 halves, which is negative 2 and a half. Okay? Anywhere that there's an x in the problem, I cross it out because it's 0. So it leaves me with 5 on top, leaves me with negative 2 on the bottom. Yet there. Okay? X-intercept tells me that I am, take the numerator, set it equal to 0. Well, that's going to be x minus 5 equals 0. So that's going to be 5, 0. And set x minus 1 equal to 0. That's going to be 1, 0. 2, 3, 4, and 5. Holes. Does it have a hole? Anything factor out from before? Nope. So that's a none case for holes. Does it have a slant asymptote? Yes. So I actually have to do x squared minus 6x plus 5, and I actually have to divide that by x minus, or is it x plus 2? Minus? No, it was minus. Yep, it was minus 2. Okay? Alright, so I have to do that. Can I do synthetic division? Yep, I can. Okay, so that's going to be 2 there, 1, negative 6, and positive 5 there. Drop it like it's hot. Multiply, add, multiply, add, and then I do what? Drop the remainder. Oops, that didn't go. Why did that not go? Oh, guess not. Guess we're frozen again. Oh well. Okay. So that tells me that my slant asymptote is, y equals x minus 4. Agree? Yes, ma'am. Not common, but I'd be okay with it. I mean, I'd probably look at you funny. So there, and there. And there. Oh, come on. Oh, I'll have to change it in post. We're going to change it right now. I can't have this. Okay. Do I have 2 zones, right? Left side and right side of my vertical asymptote. Do I have enough points on the left side of my vertical asymptote? Yeah, I would say so too. It's going to come in along the vertical or the slant asymptote, go up, hit those 2, and then go off to infinity and beyond. Okay. Do I have enough on the right side? Maybe 1 more. Okay. What if we went with 3? If I put 3 into my function, 3 squared is 9, minus 18 is negative 9, plus 5 is negative 4, over 1 would be negative 4. 1, 2, 3, and 4 right there. So it comes up here, curves in, goes out. Okay? You now have all 8 steps. Okay? Steps 1 to 1.5, to 2 to 3 to 4 to 5 to 6 to 7 to 8. Actually to 7. Okay? Alright? So you have now enough information to completely do homework packet B. We decided that those were due on